All right, this is the Topic 7 Systems of Equations study guide. We'll work out each question one by one with the work being shown. So number one, it says consider line 1 and line 2. So line 1 is 2x minus y equals negative 3. And line 2 is negative 6x minus 2y equals negative 6. And question 1 states, is 0, 3 a solution for line 1? So remember, this is line 1 here. So if it's a solution, that means this point came from this equation. Well, if a point comes from an equation, it has to work in the equation. So the way we see that if this works in the equation is we substitute our numbers in. So the x value is a 0. So I take their x, I turn it into a 0. The y value is a 3. So I take out their y, I put in a 3. And now I see if this is a true statement. 0 minus 3 equals negative 3. That's true. So yes, it is a solution. And in your explanation, you would say yes because it works in the equation. You can't just say yes or no because then that's just simply guessing. You have to give me an explanation of why it is or why it is not. Then part B of question 1 wants to know, is 0, 3 a solution to line 2? So now we're going to check this one, line 2, with the same coordinate 0, 3. So the x is a 0, so we turn it into a 0. The y is a 3, so I turn it into a 3. And now I evaluate. This gives me 0 minus 6 equals negative 6, and that is true. It is a solution. So at this point, we should know what the answer is for the system. If a point works in both equations, so if a point works in both equations, that means it's on both lines. And that's what we're looking for. When we're looking for systems, solutions, or points of intersection, we're looking for the point that is in both equations, which means it's on both lines. So then on part C, where you had to sketch the graph, I'm not going to do the sketch down here, but when you make the graph, your graph should hit at the point 0, 3, both lines. You have one line that's going up from left to right, and then your other line is going down from left to right, and they're hitting at the coordinate 0, 3. So then part D says, what is the solution? Again, the solution is the fancy way of saying the POI, which is 0, 3. All right, on to number 2. We have a word problem. And so a good thing to do with word problems is identify the important information. So it says there's a pumpkin juice drinking competition. Tatum is our first competitor. She currently has 4 ounces in her belly. And it says she's drinking at 3 ounces per minute. And we're going to have to make an equation for Tatum. So we identify what are the two things we're measuring. Well, we're measuring time, which is minutes, because this is a competition. And then we're measuring how much juice they each get. So to get Tatum's total juice, you start with how much she started with, which was 4. Now she's adding 3 every minute. Well, we don't know how many minutes are going to go by. So we say 4 plus 3 times m. If you do that equation, the final number that comes out is how much juice. So that's what I'm going to say is J. So that would be Tatum's equation. 4 plus 3m equals J. Now Kiara, same competition, she has 2 ounces in her belly at the beginning. And she is drinking it at 4 ounces a minute. So therefore, if we want to know how much juice she has, she starts with 2. She's adding 4 every minute. So 4 times the number of minutes tells us how much she's added. Add that to her initial 2 in her belly, and that gives you her total juice as well. You don't have to use J and M. If you chose X and Y, you would just have to tell me what X stood for. So if X was your minutes, you would write X equals minutes. But if you use letters that make sense, like with the words they're describing, you don't have to tell me that then. All right, on to number 3. Number 3, we're actually doing the solving. So this says x equals 6 minus 2y and 3x minus 4y is equal to 28. So what we have here is when we're looking for a POI, we're looking for an x value and a y value. Well, they don't tell us an x number or a y number, but they do tell us something. They tell us what x is equal to. X is equal to a 6 minus 2y. So when I see this x over here, I now know what to put in for it. I know that the x should have been a 6 minus 2y. So now I have 3 times 6 minus 2y. Now I rewrite the rest of the equation, minus 4y equals 28. Now I can figure out what y is, because I only have y. So I just do our basic algebra. So we do distributive property. So 3 times 6 is 18. 3 times negative 2 is negative 6y. Minus 4y equals 28. I now can combine like terms. So I have a negative 6y and a minus 4y. So that's 18 minus 10y is equal to 28. Now I can isolate the y by subtracting the standalone. So I subtract 18 from each side. So negative 10y is equal to 10. I divide each side by negative 10, and I get y is equal to negative 1. So now I have an actual number for my point of intersection. I know that the y has to be a negative 1. So to get the x, we take this negative 1 and we plug it in. And you can plug it in to the second equation or the first. You pick the one that looks the easiest. I think the first one looks way easier. So x equals 6 minus 2 times negative 1, which that gives me 6 plus 2, which gives me an 8. So my point of intersection is 8 comma negative 1. After you finish the test on Thursday, I recommend going back to each question where you had to find a POI, plug the x into the problem and plug the y into the problem and use your calculator to see if it works. And if this point works in both of the equations, then you have the right answer. If it only works in one of them, you know that you could mark it wrong for me already, so that you would want to go back and rework the problem out. Alright, number 4a, it says, what do you have to have infinite solutions? So this is number A for 4. Infinite solutions means the lines hit each other all the time. Well, in order for two lines to hit each other all the time, they have to be the same line. So that's what we're looking for on A. They have to be the same line. On B, it says, what would happen if there is no solution? Well, if there's no solution, that means the lines don't hit each other. And there's only one kind of lines that don't hit each other on a singular plane, and those are parallel lines. So if you have parallel lines, the lines will never hit. So that means you have no solution at all. Moving on to number 5. Number 5, we have 4x plus 6y is equal to 32, and 3x minus 6y is equal to 3. So on this one, when we're looking for our POI, which is an x and a y, they don't tell us what x is, nor do they tell us what y is. So I can't do what we had done just a second ago, where I took the x and plugged it in, because you can't plug anything in because it doesn't tell you what x or y is equal to. So we use our second method of systems, which is the elimination method. And with the elimination method, you're trying to eliminate a variable. And the way you do this is either adding or subtracting your equations. So if I were to add these, 4x plus a 3x is a 7x. A positive 6y plus a negative 6y is 0. So we've eliminated the y's. 32 plus a 3 is 35. Well, the whole reason we wanted to eliminate is because now we've got an easy equation. If 7x is 35, then we know that x has to equal 5. So once we know that the x value is 5, to get the y value, we need to plug in. Again, you've got two options. You pick the equation that looks easier. I'm just going to pick the one with smaller numbers, the 3x minus 6y equals 3. So the x is 5, so that x in this equation turns into a 5. So 3 times 5 minus 6y equals 3. So that's 15 minus 6y is equal to 3. I then subtract 15 from each side. So I have negative 6y equals negative 12. Divide by negative 6, and I get y is equal to 2. So now I have the second point, or the second coordinate of the y, which is 2. So at 5, 2 is where these two lines would have hit one another if we were to graph them, which we don't like graphing them because it takes too long, and it's not as accurate. Number 6, we have 5x plus 6y equals negative 8, as well as 2x plus 3y equals negative 5. Well, now we run into an issue, because if you add, you get a 7 and a 9, so nothing was eliminated. If you subtract, you get a 3 and a 3. Again, nothing was eliminated. So the trick with elimination is that you have to have the same number in front of one of your letters. So we can fix this. If I take this equation on the bottom and multiply it by 2, I now get a 4x plus a 6y equals a negative 10. I now have a 6y from the bottom and a 6y on the top, which means I can now do elimination. Now here's where some people have been struggling. We would technically have to subtract these in order to get rid of the y's, because 6 plus 6 would give you a 12. So 6 minus 6 would give you 0. But the negative signs have been throwing a lot of people off. So what I've been telling students to do is, instead of subtracting, always add. You can always add. But I know I just said that if we added these, it doesn't eliminate the y's. So what we're going to do is change everybody in the bottom to their exact opposite. So negative 4, a negative 6, and a positive 10. So now if we add, things will get eliminated. 5 plus negative 4 is a 1x. 6 plus a negative 6 is nothing. Negative 8 plus a positive 10 is a 2. So we now have our x-coordinate. Our x-coordinate is 2. Now we need the y. So we do what we've done on the last 3. We're going to plug in. I pick one of the original equations because they always have smaller numbers. So I'm going to use our 2x one. So 2, now x we know is really a 2. So 2 times 2 plus 3y equals negative 5. So that's 4 plus 3y equals negative 5. 3y equals negative 9, because I subtracted 4 from each side. Divide by 3, and I get negative 3. So 2, negative 3 is our answer to number 6. Number 7 would be the trickiest one that you're going to see for elimination method, because here's what happens. We've got a 2x minus 4y equals negative 22, and I've got a 3x plus 3y equals 30. Well, here's the issue. You can't multiply 2 by a number to make a 3, or multiply 3 by a number to make a 4, unless you want to multiply with fractions, which hardly anyone ever wants to do. So what we're going to do this time is we're going to have to multiply both of our equations by a number. So you decide, who do you want to get rid of, x's or y's. So I'm going to pick x's. So this is a 2 and this is a 3. So I need to find a common multiple of 2 and 3. Well, one of the easiest ways to find a common multiple of two numbers is just to multiply them. 2 times 3 is equal to 6. So that's what we want in front. I want a 6x in the first one and a 6x on the second one. So then you just ask yourself, what times 2 is 6? Well, we just did it. We know it's got to be a 3. So we're multiplying everything by 3. So 6x, negative 12y, and negative 66. And then I'm going to multiply the bottom one by 2. So that's going to be 6x plus 6y is equal to 60. So again, I like to always add, so I see if that works. 6 plus a 6 doesn't work. That gives me more. So that's my cue to turn everyone on the bottom to their opposite signs. So here we go. 6 plus negative 6 is nothing. Negative 12 plus a negative 6 is a negative 18y. Negative 66 plus a negative 60 is a negative 126. Now to solve for my y, I divide each side by negative 18. And that's going to give me a y value of 7. So I now have the y coordinate of my POI. Well, again, to get the x coordinate, we have to plug in. And you pick the one that looks the easiest. This time I'll use the top. So 2x minus 4 times 7 is equal to negative 22. So negative 4 times 7 is a negative 28. So 2x minus 28 is negative 22. To get rid of the minus 28, I'm going to add 28 to each side. That's going to give me 2x is equal to 6. I divide each side by 2, and I get x is equal to 3. So 3 comma 7 would be my POI for the following problem. Moving on to number 8. We have x minus 2y equals 3, and 8x minus 16y is equal to 24. So I look at my x's, and there is a way to get an 8 in front of this x. I can multiply this entire equation by 8. So that would give me 8x minus 16y equals 24. The bottom we don't change. 8x minus 16y equals 24. And we can stop here, because at this point I realize that these are the same equations. Well, just like we said earlier, if you have the same lines, that means they hit all the time. So the answer is infinite solutions. But let's say you didn't realize that, and so you start going through the process. So you got your 8's in front. We like to add. Adding doesn't work, so I turn everyone to their opposites. So now I get 0 plus 0 equals 0. Well, that's a true statement. And just like back in September when we solved for variables and we got true statements, we always wrote down infinite solutions. Number 9, we have x plus y equals 3, and we have y equals negative x plus 5. Well, this time, we now don't have to do elimination, because they tell us what y equals. Y is a negative x plus 5. So I go to my first equation, I take this y out, and I put in what it really is, a negative x plus 5. So I have x minus x plus 5 is equal to 3. So I combine like terms. X minus x is nothing. I get 5 equals 3. That doesn't make sense. That's false. So therefore, this is no solution. Which means that they don't ask you, or don't ask you in there, but that means that this technically is a pair of parallel lines. Now on to another word problem. So if you look on your study guide, you can see the word problem. I'm not going to write it all down for you. But we've got Gabe, Ethan, Drew, and Aaron are selling bottles of hot sauce and scissors. They sell a total of 19 items, so I'm going to write that down. 19 items sold. It says 19 items sold for a total of $153. The hot sauce is worth $15 a piece, so hot sauce is equal to 15, and the scissors are equal to $4 a piece. So the minute you see the word items, that's going to be your variable. So the hot sauce, we don't know how many we sold, nor do we know how many scissors we sold. We know we sold a combination of the two, but we don't know how many of each one we sold. So when it says you got 19 items, that means if you add your hot sauce plus the scissors, there was 19 things that you had sold when you combine the hot sauce and the scissors. Then it says you made $153. Well, to figure out how much money you would make, you'd multiply every hot sauce bottle you sell by $15. You'd multiply every scissor that you sell by $4. If you add the hot sauce money plus the scissor money, that gives you your total money, which is $153. Now you've got your equation. Now we would use elimination because we don't know what h is or what s is. So I'm going to try to get rid of the s's because that's the smaller number. So if I multiply this by 4, I would now have 4h plus 4s is equal to 76. I'm not going to change the bottom one. 15h plus 4s equals 153. Again, I always like to add these together, so we see if that works. It doesn't, because 4 plus 4 is 8, so that's my clue. Turn everybody to their opposite. So 4 plus negative 15 is negative 11. 4 plus negative 4 is nothing. That's how we eliminated them. 76 plus negative 153 is negative 77. So therefore, h has to equal 7. So now all we need to know is the scissor count. Well, remember it says 19 items were sold. So if 7 of them were hot sauce, so 7 plus the scissors gave you 19 items, that means the scissors had to have been 12. So that is your combo of how much you sold in order to make $153 and to sell exactly 19 items. On to number 11. Number 11, we have another word problem. So we're going to write down the important information. It says that we're doing a shuttle service to go to the airport. There's two companies. There's the Fast Shuttle Company, which charges a $5 pickup fee. So that's what you have to pay no matter what. And then you pay 25 cents a mile. So the farther you go, the more you pay. But whether you go 1 mile or 1 million miles, you would pay just the one-time $5 pickup fee. Then you've got the other one, which is called the Steady Company. They charge a $2 pickup fee. So it's less to get picked up, but their fee per mileage is 50 cents a mile. And this is where a system of equations would be used in the real world when you're trying to figure out what company to pick. You would want to pick the one that costs the least amount of money for you. So if you're going not far at all, then probably the steady one. But if you're going fairly far, you'd pick the fast one. Well, the question is, where's that break-even point? Where do they cost the same amount so you know who to pick? So fast shuttle is 5 plus 0.25 m is equal to C, the cost of your trip. Steady shuttle is 2 plus 0.5 m, and that gives you the cost of the trip. So now the question on part A, we've got our two plans costing the same amount. So we need their costs to be the same. Well, same means equal each other. So the fast, which is 5 plus 0.25 m, has to cost the same as steady, which is 2 plus 0.5 m. So now we can pick up by solving. So I'm going to subtract 2 from each side. So I now have 3 plus 0.25 m is equal to 0.5 m. I can now subtract 0.25 m from each side, which gives me 3 equals 0.25 m. To get rid of that 0.25, since it's a multiplier, we divide. And so we get 12 is equal to m. So at 12 miles, it doesn't matter who you pick, you're going to pay the exact same amount for the service. So then part B says if the airport is 20 miles away, which company should you choose? So if I go with Fast Company and I go 20 miles, that's 5 plus 0.25 times 20. And if we do order of operations, that gives me $10. If I go with Steady Company, that's 2 plus 0.5 times 20, which gives me $7.50. So the company we should pick is the Steady Company, because it will cost, even though we're paying more per mileage, it's still going to cost us less. All right, moving on to number 12, where we have the system of inequalities. So when you do systems of inequalities, the key thing is you're not doing anything different than what you did last chapter. You're going to graph the same that you've always graphed, except now you're looking for where the two shadings will overlap each other. So I'm just going to make rough sketches. So this is slope-intercept form. So that means -2 is our slope, 1 is our y-intercept. So we start our first point at 1. Slope is -2, which means you go down 2 and over 1, which puts you right here. Then I look at my arrow. This is an open circle, so I would use an open line. Now I use my trick of shading that we learned this chapter. This says y is greater than. Well, if you want to get big y's, there's only one way to go from your line. You would have to go up to get bigger y's. So we would shade everything above our line. Now we graph the second inequality. Slope-intercept again, so the y-intercept is a 3. So I started at 3. The number in front of here is really a 1, so the slope is 1. So we go up 1 over 1, which puts me right here. This is a closed circle, so I would use a closed line. And now I do the shading. This says y is less than. So if you're on your line and you want to get smaller y's, you would have to travel under your line. So we shade everything under the line. So the question is, where are the answers? Well, the answers are in the double shaded. This is your solution area. Because if you pick a point from this section and you plug it into the inequalities, it will work in both of them. That's the key thing. It has to work in both. If you pick something just from this blue area, it's only going to work in your second inequality. If you pick something from the yellow area, it only works in your first one. If you pick something from the white, it doesn't work in either of them. But something from the double shaded works in double the inequalities, which are both of them. Alright, now we go on to 13. We have Norton is going to work to try to save some money to become a walrus hunter. So she has two jobs. It says she's working as a cage fighter. So that means I'm going to make X my cage hours. And then she's also working as a toothpaste tester. So I'm going to make Y my tooth hours. So now we look at what it says. It says that when she's working at the cage fighting, she makes $20 an hour. So the cage pays $20 an hour. And the toothpaste tester pays $30 an hour. So if I want to figure out how much money I'm going to make for a given week, I multiply my cage hours by $20. So 20x. Then I add my second job, which was the toothpaste tester, and I get $30 for every hour I'm there. And my hours there are Y. And the goal was to make at least 120. That's the goal. So I can equal 120, or I want to have more than 120. So that would be one of your inequalities. The second one is your limitation one. It says you're only allowed to work no more than 8 hours. So you would have to add the hours from the cage job plus the hours from your toothpaste job, and that has to be no more than 8. So no more means less than, because that's the opposite of more, but you can get to 8 hours itself. So it's x plus y is less than or equal to 8. So that's for part A. Now we get into the actual graphing. So if I'm graphing this first one, we are in standard form. When we are in standard form, we like to find intercepts. So to find the x-intercept, that's when your y value is a 0, which means the y would go away. So 20x equals 120. So you're saying 20 times what number gives you 120? That would be a 6. Then you need your y-intercept. Well, the y-intercept is when your x is equal to 0. So that means the x goes away. So 30y equals 120. So what times 30 is 120? That means y would equal a 4. So now you can do your first graph. You have a point at 6. For your, actually, the x-intercept is at 6. So this is 6. The y-intercept is 4. Take a look at my line. It's solid, so that means it's going to be a solid line. Then I do my shading. I'll do it in yellow. This says y is bigger. So if you want to get bigger y's, you would have to go above your line. So everything above the line are where your solutions are. But now we have to put into account the second part of her issue. She can't work more than 8 hours. So again, this is in standard form. So I'm going to do intercepts. And this I'm not going to actually do the work for because I think we can all figure it out. Your x-intercept would be 8. Your y-intercept would be 8. So 8, 8, solid line. So we use a solid line. Now I look at what it says about the y. This says y is less. So that means you have to go under your line to get smaller y's. So we go under it. And so we see the area that has turned into the green, which is your double shaded area. That's your solution area. All of these points in here are hours that are no bigger than 8, but it's still hours that would get you at least $120. So part C says, if Norton works 4 as a cage fighter and 9 as a toothpaste tester, would that be a solution to your graph? So we're seeing if 4, 9 works. Well, we could plug them into these inequalities and check it that way, or we could just go to our graph. 4, 9 would be up here. Well, 4, 9 isn't in the double shaded area, so therefore no. Would she make enough money? Yeah, because it works in our first inequality, but she's worked over 8 hours, which she said she's not allowed to do. So C would be no, it is not a solution. And then finally on to our last topic of this unit, which was an arithmetic sequence, or arithmetic sequence as well, however you want to pronounce it. In an arithmetic sequence, there's one thing you're looking for and one thing only. There's a common difference between the numbers. So for example, if I have 3, 7, 11, 15, the difference between a 3 and a 7 is 4. The difference between a 7 and an 11 is 4. Between 11 and a 15 is 4. So that would be an arithmetic sequence, because the differences between the numbers are the same. Another way of saying it, if you don't want to think about it in terms of differences, another way to prove arithmetic sequences is you add the same number each time. So if you're adding the same number each time, you have an arithmetic sequence. So when we take a look at 14, I have 15, 11, 7, 3, -1. So I look at what's happening. To get from 15 to 11, I'm adding a -4. To get from 11 to 7, I'm adding -4. 7 to 3, adding to -4. 3 to -1, adding -4. So yes, this is arithmetic because you're adding -4 each time. But if we look at 15, where I have 7, 10, 14, 19, 25, to get from a 7 to a 10, I add 3. 10 to 14, I add 4, so I can stop right away. No. Because you added 3, but then you added 4, so it's not common. Alright, now we're going to write the rule for an arithmetic sequence. So we have 3, 7, 11, 15. So the way we write this rule is we're trying to figure out how to find any number in the sequence. So remember, this is the first number, this is the second number, this is the third, and this is the fourth. So we want to find what is the nth number in this sequence, whatever that might be, whether someone says the 80th or the 8 millionth number. So we look for a rule. We try to figure out, well, what's happening? Well, to get from one number to the next, we're adding 4. So here's a way to think about it. To get to the second number, you add 4 once. To get to the third number, you have to add 4. If you start at the beginning, to get to the third, you're adding it 1, 2 times. So we're adding it twice. To get to the fourth number, you would have to add 4 3 times, because you go 1, 2, 3. So if we're going to the nth number, we're going to add 4, 1 less than n. So we write that as n minus 1, because all of these were 1 less than the number. Second number, once. Third number, twice. Fourth, 3 times. Fifth, 4 times. So the nth is n minus 1. If you're adding multiple times, that's the definition of multiplication. So you're going to add 4 n minus 1 times. That's going to give you your increase amount. But remember, you didn't start at 0, you started at 3. So that's your first number. And this is your equation, 3 plus 4 parentheses n minus 1. Now onto the last one of the study guide. We have 8, 3, -2, -7. We're looking for the 84th number. So remember, this is the first, second, third, fourth, ... We're looking for the 84th number. So we look and see, well, what's happening in this scenario? Well, each time we go from one number to the next, we're adding -5. or you can think about it as subtracting 5. So if I'm trying to get to the 84th number, if I start at the first and I have to make it to the 84th, that means I have to move over 83 times to get there, because I'm starting on the first. Just like if I wanted to get to the 4th number, I have to move over 1, 2, 3 times. So to get to the 84th number, I move 83 times. Well, each time I'm moving, I'm decreasing by 5. So I'm going to figure out how much I have decreased by. So I do 83 times negative 5, which is negative 415. That's my decrease amount from where I started. Question is, well, where did we start? Well, we started at 8. So if you started at 8 and you decreased by 415, that means you equaled negative 407. And that would be your final resting point for the arithmetic sequence.